Now we're going to look at some examples trying to find the standard equation of a parabola where we're given either the vertex and focus or the vertex and directrix. So once again, we want to keep in mind that here we have our standard form. And if we're trying to find the standard form, whether it's going to be a vertical axis or horizontal, there's three pieces we need to find. We need to find the h and the k, so that's the vertex, and we need to find the value of p. So those are the three things we need to identify in order to come up with the equation. So if we start out with the first example here, if we're given that the focus is 5/2, 0, and the vertex is 0, 0, so in other words, the vertex is at the origin. So if we look at this, the first thing we want to look at is maybe going to a graph and actually plot the points. So we have the vertex is at the origin, and we have the focus, which is 5/2 and 0. So that means we're looking at the x-axis, and 5/2, that would be 2.5. So here we would say the focus is at 2.5. And because we know the focus is here, then we can determine that the parabola is going to open this direction because the focus is going to be on the inside of the parabola. And we also know that it's going to have a horizontal axis. So if we're looking at this being horizontal, then from above here, we know that the horizontal is going to be y minus k squared. So y minus k squared equals 4 times p times x minus h. So if we substitute into our formula, we have the vertex here, which is h and k. So if we substitute that in, we would end up with y minus 0 squared equals 4 times p. Now that's the value we need to look for. We need to find that. And then we have x minus h, which is also 0. So here we first need to now find the value of p. Well, we can look over here and we know that p is the distance from the vertex to the focus. So from the vertex to the focus, this is the value of p, and we know that this is going out to the focus, which is located at 5/2. Then that tells us the value of p is simply going to be 5/2. So we can substitute in the 5/2. And what else do we know about the value of p? Well, because the parabola is opening to the right, we know that it's going to be a positive value. So we would substitute in 5/2 for p, and now we can simply just simplify the equation. Y minus 0 squared, that would just simply go to y squared, and we can multiply 4 times 5/2. The 2 goes into 4 twice, and 2 times 5 is 10, so we end up with 10, and then x minus 0 is simply x. So we have the equation y squared equals 10x. So really, the main problem with this one is we need to locate the vertex and plot the focus, and then we can determine which direction the parabola is going, and then we can certainly evaluate the value of p, and then substitute in your h, k, and p value. Now I want to look at a very similar example. Notice this one is going to have a vertex of 0, 0 again. And I'm going to look at a very similar focus, but this time I'm going to make it a negative 5/2 and 0. So once again, I would start by locating the vertex and the focus. So we know we have the vertex is at the origin, and the focus this time is a negative 5/2. So that tells us that we're going to go 2.5 units to the left. So there's our focus. And that tells us the parabola is going to open to the left. So once again, we know that we're going to have a horizontal axis. And again, the equation is going to simply be y minus k squared equals 4p times x minus h. And we already know the value of h and k, so that would simply be y minus 0 squared equals 4 times the p-value multiplied by x minus 0. Because once again, we still have the same h and k at the origin. So now if we want to find the value of p, we know that's the distance from the vertex to the focus, and once again the p-value is 5/2, and we know here that it's going to be, in this case, it's going to be negative because the parabola is opening to the left. So that means over here we would plug in a negative 5/2, and we could simplify this to simply y squared, and now we end up with a negative 10 multiplied by x. So notice the difference between this example and the previous one. Our focus was a negative 5/2, which makes it to the left of the vertex, so the parabola is going to open to the left. In the first example here, our focus was a positive 5/2, which put it to the right of the vertex, so therefore the parabola opened to the right, which means the p-value would be positive, and down here when it was opening to the left, our p-value was a negative. All right, the next example, we're going to have the vertex is equal to negative 2, 1. And this time we're going to be given the directrix instead of the focus. And the directrix is x equals positive 1. So we're going to do the same thing as before. We're actually going to find out where's the vertex. And we have our vertex is going to be negative 2, 1. So that means we're going to go to the left 2 and up 1. And then the directrix is located at x equals 1. So over here at x equals 1, we would certainly just draw the directrix at x equals 1. Now, because the directrix is here, that tells us that the parabola is going to open to the left, because we know the directrix is going to be on the outside of the parabola. And once again, that tells us this is going to be horizontal. And the equation would be y minus k squared equals 4 times p times x minus h. And once again, we know the h and k value is negative 2, 1. So we could substitute in where we would end up with y minus 1 squared equals 4 times our p value, and then we would have x minus a negative 2. Okay, there's already a minus here in the formula, and we have a negative 2, so that's x minus a negative 2. And now, how do we find the p-value? Well, the value of p is going to be the distance from the vertex to the directrix. And we can simply count here. We're going from negative 2 to a positive 1, so we could subtract. We would have 1 minus a negative 2, which we would end up with this being a distance of 3, or we can simply count 1, 2, 3. And because the parabola is opening to the left, we know that it's going to be negative. So therefore, we would substitute in a negative 3 for the value of our p. And then all we have left to do now is simplify. So we could bring down the y minus 1 squared. 4 times negative 3 would be a negative 12. And x minus a negative 2 would become x plus 2. And there we have our equation. Okay, next we have one last example. Here we have the vertex of negative 1, positive 2. And this time we're given the focus, negative 1, 0. And once again, we're going to start by plotting the points. So we have a vertex of negative 1, positive 2. And then we have our focus, which is -1, 0. So we're going to go -1 right here on the x-axis. Which one, again, we know that's going to be in the inside, so that tells us our parabola is going to open downward because the focus is going to be on the inside of the parabola. And now this time we are going to have a vertical axis, which means our formula would then be x minus h squared equals 4 times p times y minus k. So once again, we still have the h and k as the vertex, so that's -1 and +2. So we can easily substitute that in where we would have x minus a -1 squared, 4 times our p value, and then y minus our k value, which is 2. And now we want to find the value of p, and that's going to be, again, the distance from the vertex to the focus. And we can see here this is our p value, which is going to be equal to 2. And because the parabola is opening down, it's going to be a negative value. So we will substitute over here a -2. And we could simplify this. The two negatives would make this x plus 1 squared. 4 and -2 would give us a -8 times y minus 2. And there we have our standard form of the equation. So you can see here, if you're given the vertex and the focus, or if we're given the vertex and the directrix, the first thing is to simply plot the vertex and either locate the directrix or focus, and then from that we can determine that p value and then simply plug in the value for p and then h and k. And remember, if your p-value is negative, that means the parabola is opening to the left or it's opening down. If the p-value is positive, the parabola is opening up or opening to the right.